moon attracts your girlfriend more than you. So that's basically kind of an analogy of gravity.
Professor Soborno Isaac Bari, who is known as the god of mathematics, is back in India. He will give a lecture on relativity at Sacred Heart College on June 16th, 2021.
It's a rare opportunity for all of us to listen to the global child genius prodigy Professor Soborno, and I personally welcome the Isaac Newton of the 21st century to Sacred Hearts.
Namaste, Honorable Principal Dr. John and distinguished faculty and fellow students of Sacred Heart College. And thank you, Nito Anthony, for inviting me here. I owe a very big debt to you. Now, I am very honored to be presented at Sacred Heart College. It feels good to be back to India. Anyways, let me just start with a story from 1905. So it was 1905, and Einstein was sitting in his patent office. He had just published 4 new papers, one of which, the paper on special relativity, challenged the grant, challenged the idea and views of one of the greatest scientists of all time, Sir Isaac Newton. But first, before I elaborate on how Einstein challenged Newton, I must go back and remind you what Sir Isaac Newton himself did. And to do that, I have to go back to 2014, when I was only 2 years old. So it was April 8, 2014. I was just about to turn 2, and before I went to bed, I asked my dad, "Daddy, can you give me a puzzle for my next birthday so I can enjoy instead of cake?" Well, I didn't know if he accepted or not. Why? Well, because instead of actually giving a response, he said, "Goodbye, good night," and shut the door in my face. Ah, Dad, what a classic. Anyway, I went to bed, not knowing if my wish was granted or this would just be like my first birthday with a generic number balloon. Well, this actually was different. I woke up to my dad calling me to room 0. And when I walked outside and, looked at the garage, I noticed something different from normal. What could it be? There was something on the floor. I don't know, my 2-year-old eyes couldn't really tell what anything was. And also, there was different writing on the chalkboard, which just gibberish to me from that far away, but there definitely was something different on there. Wouldn't there be? So, I fell down the stairs. I walked gently down the stairs, and I looked in the garage. And what was in the garage? What was on the bottom? Well, it was not a cockroach, it was a book. Well, a book, right? And what was on the blackboard? Well, it said birthday challenge. Find name of author and title of book in 1 hour. I understood the message. Find writer of book, find name of book, write it on blackboard, have 1 hour. That was all that was going in my 2-year-old brain at that point. And then I broke out in laughter. Oh my God, how could this be hard? I looked at the book cover. What would be on it? Well, I expected the name, I expected the author, but what I got was damn black paint. The black paint was in the spots where the name and the author was supposed to be. So how was I supposed to find this author? And how was I supposed to find this name? I flipped through the pages, like any 2-year-old boy would do. I was trying to calm myself down so I wouldn't eat the paper up. And I saw a familiar picture on one page. It was a picture of a planet. Which planet? I mean a planet with fish. What do I mean by fish? Sir Isaac Newton threw freaking fish on it. So, who's to judge? Fish are the most important component of planets ever. I never thought I would get into the importance of fish on planets in a speech about science, but here we are. Anyway, the fish thing is now over with, and I saw the second most important thing, landscape, other than fish. And the landscape had a little tiny mountain on it. And then somebody, threw a cannonball. And I'll also say this, the moon attracts your girlfriend more than you. So that's basically kind of an analogy of gravity. What happened was that there was a cannon on the top of a mountain. Who knew? I mean, there's a cannonball. That cannon shot a cannonball at a relatively slow speed at first, and then it just drooped. But then it started to make its way around the quarter of the Earth. Then it started to go halfway around the Earth and still damn failed. After that, it started to, not come back. Its orbit started to increase and increase. And then it was off. It was orbiting stably. It wouldn't fall back down to the Earth. That was the picture that I saw. And I drew it. And then I thought for a while, like any 2-year-old would do. And what I came up with was the author would be Sir Isaac Newton, trying to comprehend what could be the name of the book. And then I got my answer. You know what it was? Cannonball! Because of course, why else would only literally one picture and an entire 1,000-page book be based off of a cannonball? My dad probably died laughing at me. Well, a few weeks later, when I was actually 3 and actually knew how to use phones and computers, I typed up, what is name of Isaac Newton's first book? And I got Principia Mathematica. That's nowhere near Cannonball. So Sir Isaac Newton, he discovered gravity. Well, there was obviously some flaws and issues with his theory, but it was much better than what any other scientist could do at the time, especially scientists in the other fields. Flat earthers were still a big force back then. In the 1600s and 1700s, gravity was a revolutionary idea. And he also used the law of universal gravity. The universal law of gravity. Sorry, got the words a little switched up there. Which states that Fg, which is fancy science term for the force of gravity, which is mysterious, is dm1m2 over r squared. Now, I know that may sound like gibberish, but what it basically means is some certain crappy number, 6.67 times 10 to the negative 11 to be exact, and times the mass of your first object times the mass of your second object divided by the radius or the distance between the two squared. So you can obviously see that gravity, the force of gravity is inversely proportional to how far you can get out between them. And I'll also say this, the moon attracts your girlfriend more than you. So that's basically kind of an analogy of gravity. So, the more mass you have, and the closer you are, then that means that you'll have more attraction. Please do not take these tips for, with girlfriends. Anyways, that being fat and more massive will only make you less attractive to them. Anyways, Newton's greater contribution other than gravity is calculus. What is calculus? Calculus is basically just derivatives and integrals. That's what it's based off of. And not all derivatives and integrals, but they're one of the cornerstones. Derivative is basically, the slope of a slope. Integral is the opposite. So, now you know. Calculus in 15 seconds. Anyway, in Newton's time, not actually in Newton's time, the physicist we're talking about was born about, 13 or so years after Newton died, which is sad. But the physicist we're talking about is Alessandro Volta. He invented the battery around 1800 or so. And that with the battery, he also got a unit of energy named after him, volt. So that's pretty sweet. Anyway, he discovered the battery. But what else was to be discovered? A few years later, Ampere discovered current. And Ampere was in France. So let's go to Normandy. Let's take a trip to Normandy. Current was discovered by Volta. And then, not Volta. It was discovered by Ampere. And then guess who linked the two together? The Germans. Was it the Germans? Greg Ohm. So Greg Ohm, he discovered the link between the two. France and, he discovered the link between France and Italy. Germany, which is kind of weird. But anyway, Greg Ohm discovered the connection between the two. And he also got a thing named after him, which is pretty sweet. All three of the scientists we mentioned all had something named after them. Also Newton, a unit of force, Ampere, a unit of current, Ohm, a unit of, volt, everything, voltage, a unit that is volt. Every scientist we've discussed so far has had a unit named after them. Coincidence? I think not. I don't have a stubble, by the way. Anyway, after that, Greg Ohm had the joy of connecting the two. And you know what Hans Oersted had the joy of? Dancing in his office. Anyways, Hans Oersted discovered the joy of dancing in his office, his small tight office, to the discoveries he had just heard of. But one day, while he changed his curriculum to current, voltage, current, then he left his compass near the wire. And no, a robber didn't break in and steal it. Instead, what happened was that a robber broke in and stole. What he did was he turned on the current switch, and suddenly the compass deflected, just like I am going to do to the camera. So the compass deflected, and he thought it was just a coincidence. Maybe this is just a coincidence, which I totally didn't just say. Maybe my compass is broken. Or maybe there's a magnetic influence. So, what he did was he called his entire class off, and then what he did was he took 7 more compasses. I don't know why he took only 7 more. And then he lined them up in 4 columns, and then he turned the power on. And all of them deflected, all 8 of them. So I'm not going to deflect from the camera 8 times. You want me to get dizzy and freaking faint? So I'm not going to do that 8 times. But you can get the idea. The compass deflected, and I think he got the gist. Because he knew that compass move equals magnetic influence. And so he thought, oh my god. That means that current carrying wire carries electric influence. Because he tested it with, an off wire, the compass didn't deflect. And that's what happened in his classroom. So, now the entire world knew. Electricity, magnetism together! But electromagnetism was still yet to be conceived. And now, we move on to the next big old scientist, Faraday. Faraday was very poor and uneducated when he was a young man. He was illiterate and poor until he was 14, when he learned basic reading and writing from a Sunday church school, like 1st grade, 2nd grade writing I'm talking. So how did he go from 0 to one of the biggest scientists of all time hero? Faraday applied for Sir Humphrey Davy's class. And then Humpty Dumpty fell over a wall and broke himself. I mean, he got accepted. Incredible step for this young man. One step for one man, he would leap for mankind, isn't it? And he did enact a huge leap for mankind. But that comes later. Instead, he was just a humble man in one of the best chemistry classes in the world, led by none other than the egg himself, Sir Humphrey Davy. It's hard to not say Humpty Dumpty, I'm telling you. Anyways, he applied for a job, but Humphrey Davy did not forget. A few years later, he applied again, and then Sir Humphrey Davy accepted. And now, Faraday was under the wing of one of the greatest practitioners of all time, rivaled by only the Frenchman, Ampere. You know him, you love him. Do you love him though? I have no idea. Who went off on his own path in 1820, and just 11 years after, on August 29, 1831, I told you I'm not a historian, but I'm lying, he discovered induction, something he had been wondering about for so long. He had seen Hans Orsted's discoveries, and that magnetic influence can be generated by current. He thought, if current can create magnetic field, can magnetic field create current? So, he took 2 copper rings, not his marrying ring, and he wrapped them around an iron ring, also not his marrying ring. Then, what he did was he moved a magnet to it. Not something you do in the early Victorian era, but still. Anyway, he found that it generated a spark of current in the lower one. And now he knew it. Induction was real. And then, suddenly, from the grave, what happened was that Alessandro Volta thought, Mamma mia! You can generate current without using batteries? So, my discovery was useless. We don't use batteries. We use induction. The next big old scientist we're going to talk about is James Maxwell. 3 out of 4. And James Maxwell is the one who made electromagnetism official, verified, done and done. So what James Maxwell did was that he took 4 equations from other scientists and mashed them up into one big soupy equation called Maxwell's 4th equation, and then they all had they all united the 2 biggest subjects in physics: electricity and magnetism. Basically, first one says that electric field is E dot dA integral. Second one says that the divergence of a magnetic field is 0 because no magnetic monopole, so it always must cancel out. Now number 3. The third one basically states that curl of electric field equals to the change of magnetic field over time. So yes, electric field is associated with magnetic field. And then they all party to, that in number 3, which is also a form of Faraday's law. And number 4 is what he did is he took, it's the only original one out of the 4. What he did is he took Gauss's law, took Gauss's law for magnetism, took Faraday's law, and then all massed the variables, all massed the equation signs, all massed everything. And that soup was named Maxwell's 4th equation. And basically it says this: magnetic flux generates electric field. Does electric flux generate magnetic field? And it also calculated the speed of light. Now the funny thing is, by calculating the speed of light, James Maxwell broke up the relationship between Sir Isaac Newton and Albert Einstein. No, not that kind of relationship. I mean a mathematical and physical bond. So, Einstein now thought, James Maxwell says that time, the speed of light, it's absolute. It's not relative. But Sir Isaac Newton says it's relative. So that means Sir Isaac Newton was wrong. Sir Isaac Newton was wrong. So, after that, in his patent office, he formulated a new thing. Something that would replace Newtonian physics. Special relativity. Special relativity was, as you know, special. Because it only worked in certain circumstances. So, acceleration was a no-go. So that means even gravity didn't work with this theory. So, his theory was that, length is an absolute, time is an absolute, hell is an absolute, heaven is an absolute, nothing is absolute. Except heaven. So, the thing was, Einsteinian physics said that nothing except the speed of light is absolute. Basically nothing. Not saying that actually. So, the thing was, he was heavily criticized for this theory. Some people said, Sir Isaac Newton was right. What is wrong with you? Some other people said, what the hell is this? I cannot understand. My brain is too small. And other people, other racists, called it Jewish pure science. And two Nazi-aligned physicist Nobel laureates, Nazi-aligned Nobel laureates in physics, attacked, Albert Einstein with a full-blown freaking racist thesis that had nothing to do with the topic, and they just wanted some power over Albert Einstein. But they were not going to get it because Albert Einstein, he formulated a new theory because he wasn't actually happy with his old one either. Probably to you guys' surprise. He actually was sad because it worked only in certain circumstances, like gravity was a no-go. So that meant that he had to make something new, something a bit general. What do you say? Maybe general relativity could help. General relativity changes up things a little. And also kind of aligned with Kendrick Lawrence stuff, goes without saying that Einstein's theory of general relativity was much better than special relativity, even though most people just want to be special in life and not be part of the general crowd. General was actually better than special, which is unusual. Anyways, general kind of changed up things a bit, and it also added a new thing. Say you have a hammock, and probably most of you don't, but say you have a hammock, or like something that's in a square shape that looks like a hammock, and it's like suspended to 4 strings. Like a hammock is suspended to 2, and so it's like suspended to 4 strings. Alright? Right? And then what you do is you take marbles. You guys probably don't have them, but take beads. Take really anything you have that is a ball, and it will create kind of a pit around it. And let's say the cloth that you have is space-time. Now these tiny masses have so little mass that they only distort space-time a little where they stand. And so that means they only drag things that are very close into them. Let's say you have a bigger marble that's even more massive, and then you drop it. Assuming your cloth or hammock doesn't break, better not sleep on there. Then the big bead will make a very large pit and will drag anything that comes even close to it right in. And that's basically what gravity was to Einstein. And that's still our model of gravity, as Einstein proved Newton wrong, and multiple other scientists have, and his theory is credited to be the best we have, and possibly even the correct one. Because we've gotten a few things correct about the universe, but special relativity and general relativity are one of the things we most likely got correct about reality. Anyways, that is the basics, without any mathy math and hacky hack on your computer, of, special relativity and general relativity. And we also talked about a few other concepts on the way, So yeah, it was a pretty nice time with you guys.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल वंग